Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about overrated super Earths, and of course, taking listener questions about all things in the universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern, and you can follow along or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about, I don't know, but first, the news. Hello, Space Cadets. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State and the Flatiron Institute, and for the next half hour, your agent to the stars. Got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get yourself on the air. You can also follow along with our Space Cadets tuning in live from around the world, including but not limited to Norg, Netherlands, Boulder, Colorado, Carroll Stream, Illinois, Santa Clara, California, and London, UK. Check out spaceradioshow.com for the links where you can follow along with those live streams. We'll take questions that you send there too. Seriously, folks, I've prepped 4 minutes of material tops, so get those calls in. Hey, sorry I didn't get you a shout out from Chile. Anti-gravity nonsense. How's it going, Space Cadets? Good to see you again. Salt Lake, St. Louis, Missouri, STLMO. I figured out your code. Jeremy Smith. How's it going, everyone? You like my little note card where I write down your locations? This is high tech. A stack of pink notes. These, you know what these are? I got these from WCBE back in the day. I just took a stack of papers. They are tardy permits. Ooh, tardy, but we'll allow it. Elijah, tardy, but we'll allow it. These are all, I never knew. I've been using these for like 2 years. This stack of pink slips. I didn't know that they were tardy slips. Okay. So if you're late to Space Radio, I got you covered. And your name matches one of these. I got you covered. Space Cadets. Dave, how could I possibly ever forget New Zealand? Who forgets New Zealand? New Zealand, lovely country. Only been once, but I'd love to go again. You guys want to hear some news? You are not from Mars, Glenn. No human being comes from Mars. Make sure you get your questions in, and Nancy will collate them and collect them, send them to me on a back channel, and I can include them in the show. I want to talk about Tess. Gravity should be... Send the question, Marcel. Let's do it. Before I start taking questions, I want to share some interesting bits of news I caught recently, and there's a new planet hunter in town, and that is Tess. Tess, the transiting exoplanet survey satellite launched by NASA about a year ago. It's been collecting data ever since then, looking for the slight dip in brightness as a planet crosses the face of its star, and we can detect that. Now, that by itself isn't good enough to just find a planet. That's a good way to find a candidate planet, to think you have a planet. But once a candidate planet is found with Tess, then we use follow-up observations with ground-based satellites to get a confirmation of that planet. But this new result coming out of Tess, instead of doing the test thing, getting the transit, and then moving on and sending the data down to ground-based observatories, and ground-based observatories start looking for the planet, instead, once they have a candidate, they go back in archives of old data from telescopes who have been staring at stars for a very long time, because astronomy is kind of an old thing. And then from the past observations, they're able to confirm the planet. So this is wild. It's like, oh, we think we have a planet, so let's dig into the archives and we can look for those other telltale signatures that we wouldn't have been able to find by themselves back in the day, but now that we think that there's a planet there, we can go back and confirm that there's a planet. So we don't have to wait another year to publish our data. We can just dig back in the archives and publish our results right away. And they found some planets. Tess is going to find a lot of planets, somewhere around 11 billion plus or minus a billion. That's not a real number, but it's a lot. That's a very scientific estimate of how many planets Tess will find. And they announced that. Now I have a little bit of issue with the announcement here. I guess. They found a planet in the GJ357 system, relatively nearby to Earth, about 31 light years away. And they found 4 planets there. One is in the habitable zone of that star. The star is a red dwarf. It's a third the size of the sun. It's rinky-dink, doesn't emit a lot of light. And so the habitable zone of that red dwarf star is very, very close into that star. And this 4th planet is in the habitable zone. So, of course, the announcements are saying potential habitable world because it's in the habitable zone of that star. It's also like 3 or 4 times the mass of the Earth. It's not an Earth. It's a super Earth. Could life evolve on a super Earth, on a planet that's 3 or 4 times more massive than the Earth? I don't know. Nobody really knows. All we know is that this particular planet is in the habitable zone of its star. So could it host life? Maybe. They're being very careful. They're saying it's potentially habitable. I go back and forth on announcements like this of whether these kinds of announcements should be exciting. Like, yes, this is technically a potential habitable world outside the solar system. Great. But if there's a potential habitable world discovered every 6 months and none of them have life on it, are we desensitizing people? Space Cadets, I'd love to hear your opinion on this, of these kinds of announcements, of whether it's right to hype up these kinds of announcements or not. Let me know in the chat, and hopefully we can follow up in the rest of the show. That's the latest and greatest when it comes to space. It's time to have a conversation. Yeah, exactly. Travel 31 light years and find a dump. What a waste of a trip. Okay, Nerdy Rodent. Good point. There could be a new sort of cheese out there. I retract the past 4 minutes of my entire discussion. Glenn, I love space radio too. All right. Tons of questions piling up. I'll take a voicemail. I seem to have found a pattern where we do a voicemail or two for the first segment in the show, and then we switch to Space Cadets for the second. Clickbait science. Good. I'll come back to this. Man, we got so many questions ready to go. This is exciting. This is science. We've got a voicemail all ready to go from Scott. So, Greg, are you ready? Play the tape.
Hi, Paul. This is Jason from St. Louis, Missouri again. My question has to do with black holes. My friend and I had a debate, and I wasn't sure about this. When items get sucked into a black hole, they get destroyed, obviously, because of the gravity. My question is does the item or whatever gets pulled into a black hole, does it get 100% crushed and destroyed to where it just completely disappears? Or is it so small that it could go through a black hole because it has nearly zero mass, and then possibly once it goes through the black hole, gravity starts over again and the whole process of stars reforming starts over again? I know there's some theories in it, but I just didn't know if something so small could get destroyed to where it completely disappears. So any help, I'd appreciate it. Thanks.
That was an awesome question, and that was not Scott, and I will not blame Greg for that mistake. That was my mistake. I sent the wrong file to Greg. That was Jason. Jason asked a wonderful question about black holes and things falling into black holes and basically what happens. What's the story? We know the story outside a black hole. Something falls into a black hole, falls within the event horizon. It is gone forever. It is not ever coming back. Why? Because to escape a black hole, you have to travel faster than the speed of light, and you can't, so you won't, and you don't. You stay inside the black hole. Once you fall into a black hole, once you cross that event horizon, you will end up reaching the singularity. The singularity is the point of infinite density where nothing can resist gravity. Gravity is the ultimate victor, the ultimate force. Nothing can resist it. And so it just pulls and pulls and pulls and pulls and pulls everything down, and nothing can fight against it. So it squishes into an infinitely tiny point. We know that everything I just said is wrong. This is black holes appear in the theory of general relativity, Einstein's theory of gravity. We know that black holes exist. There are things, we have literal pictures of black holes nowadays. What's at the center of the singularity, that's predicted by the mathematics of general relativity. But the singularity, that point of infinite density, that's where general relativity stops. That's where it's saying, hey, stop listening to me. I don't know what's going on here, but I don't have the machinery to compute what's actually happening at the center of a black hole. So I'll just say singularity as like a big red flag that you should stop listening to me, and you should figure out some other physics to explain what's happening in the singularity. We don't know what's at the center of a black hole. For now, we're calling it the singularity as a placeholder. That's what's predicted by general relativity, but we know general relativity breaks down at the center of a black hole. And this is where Jason mentioned various theories. There are various ideas of what might happen when you fall into a black hole and you hit that singularity. You get crushed. Don't worry about that. You're not going to survive the journey. You will be atomized. You will be subatomized by the time you reach the whatever is in the singularity. Some people have theorized that instead of a singularity, instead of an infinitely dense point, there's just like a little tiny nugget of stuff that's just super tiny, and you just get glued onto that, squeezed down to subatomic scales, and then you just hang out there forever. That's one option. We don't know. Other people have hypothesized that maybe something funky goes on, like maybe there's tunneling or wormholes that pass you off inside the black hole and out into another universe or another part of the universe. We don't think that's right because wormholes in general are unstable. That's pro tip for any interstellar travelers. If you encounter a wormhole in the wild, please do not travel down it because it will instantly disintegrate and you will be torn apart into a million pieces. It is like real life is not a TV show, folks. We don't think wormholes are stable, but we don't fully understand what's happening at the center of a black hole. So maybe it's something else. Maybe your thin subatomic stream of atoms get passed through and dumped into another universe. Maybe they get glued onto some little plank-sized nugget happening in the center. Maybe none of the above. Maybe it's all just a big joke. We honestly don't know. This is at the boundary, past the boundary of known physics. If we knew, like if I knew right now, I would be prepping my Nobel Prize acceptance speech. That's how big of a deal this is. And I'm not prepping my Nobel Prize acceptance speech, which means I don't know. So thanks for the question, Jason. I would love to give you an answer, but this is a part of the universe where we simply don't know. Thank you again, Jason, for that question. We're going to take a quick break. Don't forget to leave a voicemail to join the conversation or catch the live streams on YouTube and Twitch. Go to spaceradioshow.com for all the links. I'm Paul Sutter. This is Space Radio, and this show is brought to you by you good people. That's right, you generous citizens. By going to patreon.com/PMSutter, you can keep this show going for as little as $1 a month, as much as infinity dollars a month. And I'll see you after the break. What are the main problems with keeping a wormhole stable. Okay, nerdy rodent, I think I will answer that. But I want to go back and collect some of your responses about Tess, whether we should hype it up or not. Would gravity always be great? Yeah, okay. I'll talk about some of these super Earth questions. Very good, Nancy. You pulled a nerdy rodents question about cheese. Yeah. All right. I think I'll start by following up on the whole super Earth thing. Yes. How's it going, guys? I love reading all your comments, by the way. Please keep them coming. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions ready to go, but remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. Now, the Space Cadets have been a babble all about Tess and exoplanets and super Earths and whether it's overrated. And I have a few comments here. Drunken Ramble over on YouTube is saying, yeah, just... is it worth traveling 31 light years just to find a dump? Like, super Earth, like, no one wants to live on a super Earth. Some people are calling this, George Lancaster is calling this clickbait for science. Is that valid? I don't know. Ioannis is totally desensitized and is ready for the aliens. I'm not exactly sure what that means, and I am not going to ask further. But, Nerdy Rodent on YouTube is asking, could there be a new sort of cheese out there? Now, this is something that I believe no one in the cheese world has investigated, what the effects of extreme super Earth gravity would have on the cheese formation process. Could there be new varieties, new flavors, new textures, new all of the above? Maybe it is worth traveling 31 light years to a super Earth orbiting a red dwarf star just to experience the new kind of cheese. Very, very valid question. Gordon Lee is asking, if we were to find a super Earth, which we did, and the conditions were 100% to our liking, which we don't know yet, because of the mass of the planet, will the gravity always be greater? In general, yes. You and me probably would not survive on this newly discovered planet. Like, if we were to land on the planet, you were to get off, you would be heavier. I don't know exactly how much heavier. It's not, even though the planet is 3 times the mass of the Earth, if it has a larger radius, that would drop your gravitational pull. If it has a shorter radius, that would increase the gravitational pull. So what you would experience as your weight will be somewhere around, say, 2 to 5 times your weight here on the Earth. And maybe you could technically survive for like the day, but your body's going to wear down real fast. Like, our human bodies are adapted to the Earth. This is where we grew up. This is where we evolved. This is all of our biomechanics and biochemistry are tuned to this gravitational environment. That's why astronauts in low gravity environments have such a hard time. And if we were to try to colonize this planet, good luck. You can try it first, Gordon, and let me know how it goes. Scott Polloth over on YouTube, one of the Space Cadets, is asking if the atmosphere is, or if the planet is in a red dwarf sun, wouldn't any atmosphere have been burned off? Yeah, that's another big challenge with these red dwarf stars. Yes, red dwarf stars are common, the most common kind of star in the galaxy, but they're very volatile. They're very temperamental. They can wildly change in brightness, like 50% over the course of a few weeks. They have major flares. They just just explode. And because the habitable zone, the zone where liquid water could exist on the surface of the planet, is so close to the star, anytime it has this fit or it gets angry or just an outburst, like, the planet gets a full blast of it because it's right up against it. This is bad news for life, folks. If you had to guess, you would guess that you would not find life orbiting a red dwarf star just because it's so hazardous. It's so dangerous. It's just not any fun. It might be so bad that the atmosphere might have gotten completely blown off. Maybe the planet has enough gravity, it has enough mass that it can hold on to that atmosphere, but maybe not. Maybe not. We just don't know. We're so ignorant, which is what makes exoplanet investigation so much fun, is we're learning things, new things every single day. Also, Marcel over on YouTube going very, very hypothetical here. Could we, in theory, see traces in space of spaceships going very close to the speed of light, like 99.9996% the speed of light, like strange redshifts or something? If a spaceship were to be traveling close to the speed of light, I don't think we'd see the spaceship itself because it'd be tiny. But the amount of energy required to get an object close to the speed of light, especially a massive object like a spaceship, it's like multiple Earth-destroying nuclear bombs going off every single microsecond to get you that close to the speed of light. That's a lot of energy. That's a lot of heat. That's a lot of particles generated. That's a lot of exotic particles generated. Would we, in principle, see it? Maybe. Would it be indistinguishable as a sign of aliens doing donuts around the galaxy? I don't think so, because nature herself is very, very good at high energy processes and blowing things up and consuming a lot of energy and making exotic particles. So if we saw that, if we saw like, wow, a flash, our most likely candidate would be a star blowing up or things merging together or something falling into a black hole. It's one of the many, many, many energetic exotic processes that nature is capable of doing all by its lonesome. So maybe in principle we could detect it, but I don't think we would recognize it as a spaceship traveling that fast. Nerdy Rodent YouTube is following up. What are the main problems involved in keeping a wormhole stable? All of them. All the problems are involved with keeping a wormhole stable. The real challenge, like wormholes by definition are unstable. Just the way they're constructed in gravity, the way you have to fold space-time to make that tunnel just isn't stable. It's like, yes, you could take a pin and balance it precariously on its tip, or a pencil, and you could, if conditions were just right, you could balance that pencil. It's allowed, but as soon as you breathe on it or like look at it wrong, it's going to fall over. Same thing with a wormhole. If even a single photon, a single bit of light travels down the wormhole, it destabilizes and the wormhole will close faster than the speed of light. So one bit of light can't even make it to the other end before the whole thing destabilizes and evaporates. If you want to stabilize a wormhole, you need to thread it with negative mass. And for those who are just listening to this on the radio or podcast, I'm giving you a very deep shrug right now. I don't know what negative mass is. It doesn't exist. If it did exist, we can make stable wormholes. As far as we know, it doesn't exist. Last question before we go. J.I. Pearson on YouTube is asking, could the aliens on a planet that's 3 times bigger than the Earth, on one of these super Earths, even send up rockets? Think of how hard we have to work to get off the surface of the Earth with just 1G, just fighting 1G, and actually have orbits and stable and actually have some sort of presence in space. If it was 3 or 5 times harder, that's honestly a really good question. Could chemical rockets even do it? Maybe not. Maybe not. They might be earthbound for their entire history of their civilization, which is Kind of sad, but their problem. Thank you for all these amazing questions. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. Can you believe we're almost out of time again? I know. Jeremy, does that mean you can destroy matter by throwing it into a wormhole? If the wormhole was purely vacuum, and then you toss something into it, then yes, it would destroy something. But if even one bit of light, and there's light kind of everywhere in the universe, enters the wormhole, it's done. It's done. Just stay away from wormholes. Please. Do whatever you want. I'm not your boss. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. You know what my 3 favorite words are? I don't know. This isn't a trick. I'm not saying I don't know what my 3 favorite words are. I'm saying my 3 favorite words are, quote, I don't know, end quote. Those are my 3 favorite words. I got to say it today. Likely I said it last week. Very likely I said it the week before. Very likely I said it the week before that. I got to say, I don't know what happens at the center of a black hole. I got to say, I don't know if life could survive on a super Earth. I got to say, I don't know if a super Earth can even have an atmosphere surrounding a red dwarf star. I don't know. Sometimes all I say in one of these shows is I don't know, or a very extended version of the phrase I don't know, to explain why I don't know and why nobody knows. I don't know is a powerful phrase. I don't know is where science starts, right? Once we figure something out, once we actually do know, then it's, general body of knowledge. It's just facts and grounded theories and things we understand. The actual science is done by starting with I don't know. So if you learn science and you're just learning the facts, that's fun, that's a part of it for sure, but that's not where the science happens. Science happens at the edge of knowledge. Science happens at the edge of understanding. It's a toolkit for pushing that boundary further. It's by saying I don't know, liberates us. It frees us from bias and assumptions. It allows us to do this whole science thing. I don't know is one of the most powerful things you could possibly say. Because by admitting that you don't know, that's when you can start to learn new things. If you already know, then you've closed off your mind. Then you're done. Then you figured out you don't waste brain power. You just know. What's the point? You don't need science there. You don't need curiosity there. You don't need exploration or discovery in the known. You need it in the unknown. And to explore the unknown, first you have to acknowledge its very existence. And that's by saying, I don't know. So if you want to, if you're listening live, you're listening recorded, I want you to say it out loud with me. I don't care if you're in public. This is a good, healthy exercise. Ready? 1, 2, 3. I don't know. And unfortunately, I do know that this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/PMSutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio 90.5 FM in Columbus for making this show possible. Catch the live stream every Thursday at 4 p.m. Eastern. Visit spaceradioshow.com for all the info and the links. You can also follow me on all social channels at Paul Matt Sutter. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. I don't know. You said it. You guys said it. We all said, I don't know, together. We did it. We don't know. If we knew, I wouldn't have a show. Or I would have a show, but it'd be way less fun. Because I would just read facts to you. And who wants a list of facts? You do, probably. Thank you again, Space Cadets. I will not be recording. Hey, and by the way, I'm in my new setup in a new studio, Spaceman Studios in New York City. But I will not be recording next week, but I will be back on the air the week after that. So enjoy the break. Come up with lots of cool sciencey questions. And